Alright guys, we are looking at another method of solving. This one is solving by finding square roots. So still dealing with those quadratic expressions and equations, we are going to use just a different method to solve today. So this is a radical, that kind of check mark thing. Hopefully you've heard that term before. What is underneath the radical is called the radicand. So that's probably a new term for you. So the radical is the square root check mark shape. The radicand is what is underneath the radical. So properties. If you have a and b multiplied underneath the radical, we can separate that out. So in this case, that would be the square root of a times the square root of b. We can do the same thing if they're divided under the radical, and we can separate them out into separate radicals. So the square root of a divided by the square root of b. That's going to help us in some of our solving. Simplified form means no radicand has a perfect square factor. No radical in the denominator. We need to rationalize. So when we simplify the square root of 500, we need to find the largest perfect square that will divide into 500. So remember, perfect squares are 1, 4, 9, 16, 25, 36. It's something that multiplies by itself. So our largest perfect square in 500 is going to be 100. And 100 times 5 gives you 500. Well, we're going to use our rule that when we had the square root of a times b, we can separate that out into the square root of a times the square root of b. So in this case, then, the square root of 100 is just 10, and then we bring down that radical 5, or in this case, the square root of 5. Alright, and this next one, I'm going to use that rule in reverse. I'm going to go ahead and take that 12 and that 6 and multiply them together. So I end up with 72 as my radicand. And then I want to come up with the largest perfect square that I can take out of there. So that 3 is still going to be up front. And I think 36 is the largest square. And then I have 2 left over, so 36 times 2 is 72. Square root of 36 is 6, and then I bring down radical 2. 3 times 6 then is 18, and bring down that radical 2. Since we can't simplify the square root of 2, we are finished there. Now in this one, we can use our division rule and put the 25 on top separate from the 3 on the bottom. Now, we know that the square root of 25 is 5, but one of our rules was that we cannot leave that radical in the denominator. So think back to Algebra 1 when we had to rationalize the denominator. We don't want to change the problem. So when we multiply, we're going to multiply it by a fraction where we have the same thing on the top and the bottom. And the way to get rid of the square root of 3 is to multiply by another square root of 3. So when I do that, I want to put the square root of 3 on the top and the bottom so that I haven't changed the problem. Just like 5 over 5 gives you 1, square root of 3 over square root of 3 also gives you 1. So we haven't altered the problem. Then when I multiply across the top, so I get 5 radical 3 over, now you can look at this in one of two ways. The square root of 3 times the square root of 3 then is the square root of 9, Or you can just think about that we know the square root of 3 times itself is going to just be 3. Either way, this simplifies down to 3 in the denominator. We've now cleared it of any radicals, so we are good to be done at that point. Alright, solving quadratic equations without an x term. So if we don't have that middle term, one thing we could do is solve by finding the square root. So in this case, I'm not going to move everything to one side. I'm going to try to get the x squared isolated by itself. So I'm going to move this 3 over to the other side by subtracting. I end up with negative 5x squared equals negative 12. Then I'm going to divide by negative 5 so I can continue trying to get x squared by itself. So I get x squared equals positive 12 over 5. And then I want to take the square root of both sides. So now I get x equals, and anytime I take the square root, I don't know whether my answer is positive or negative. So plus or minus, I'm going to go ahead and separate the square root of 12 over the square root of 5. Now, problem, because that 5 is in the denominator, so I need to multiply by radical 5 over radical 5. That's going to be plus or minus. 12 times 5 gives me 60 over 5. We're still not done though, because the square root of 5 is not as simplified, or the square root of 60 is not as simplified as we can get. We can take this even another step further and say in 60, my largest perfect square is 4, and 4 times 15 would give me 60, and then I still have 5 in the denominator. The square root of 4 then is 2, and I bring down the radical 15 and the 5 in the denominator. And that is your final answer. All right, this one looks complex. If you want to pause the video here and try to solve this one on your own, go for it. It's a great chance for you to. One thing I normally see, especially if you have stopped and paused the video, is students try to take that x minus 2 and multiply it out. So x minus 2 times x minus 2, they end up with a big mess with an x term, and they're trying to factor and solve, and it's just not working for them. Even easier would just be to divide both sides by 3. I end up with x minus 2 quantity squared equals 7. Well, I know anytime something is squared, to get rid of it, I want to take the square root. So if I take the square root of this whole quantity that's squared, it's just x minus 2. Now on the right hand side, it's going to be plus or minus, since I took the square root. So plus or minus radical 7. And then I still want to get x by itself, so I need to add 2 to both sides. So I end up with x equals 2 plus or minus radical 7. That is a whole lot easier than if you tried to multiply all that out and try to factor or something along those lines. Okay, just a question for you. Which would take longer to fall, a feather or a book? We're talking about being in a vacuum here. So what do you think? Well, objects near Earth fall at the same rate regardless of weight. We know we're not in a vacuum, so you may have said that the feather would take longer because it would catch some of the air, whereas the book wouldn't. But in physics, we typically operate in a vacuum, and so they would fall at the same rate. And that rate then is right here. So on any planet, the height of a falling object can be found by this. Opposite of g over 2 times t squared plus h sub 0, where h is the height after t seconds, t is the time in seconds, g is the acceleration due to gravity, and h sub 0 is the initial height where we started. So note, on Earth, the acceleration due to gravity is 32. So if we're on Earth, this becomes the opposite of 32 over 2, or 16 t squared plus our starting height. And so if we're working with this equation, then how long would it take a penny to drop from 1,450 foot tall cliff? So how long would it take it to drop? When would it hit the ground? When would the height be 0? So we said our equation there was h equals negative 16t squared plus h sub 0. Well, when would h be 0? We're looking for the time if we started at 1,450 feet. So to solve that, I would subtract 1,450 from both sides. And then I get negative 16t squared equals negative 1,450. I'm going to divide by negative 16 so that I just have t squared. And I get 90.625. I take the square root of both sides, and I end up with t is approximately 9.52 seconds. Now, technically it would be plus or minus, but since we're talking time, we only use the positive there. Alright guys, that is all for today. If you have any questions, please come in and see me. I will see you in class.